after reading into something a bit heavy with respect to the law of equimarginal utility, let's move on to a fairly easy portion, which is a derivative of demand curve and the law of demand. We now turn to explain how the demand curve and the law of demand is derived in marginal utility analysis. As stated above, the demand curve or law of demand shows the relationship between price of a good and its quantity demanded. We've read this over and over and we now know what all of this means. Marshall derived the demand curves for goods from their utility functions. It should be further noted that in his utility analysis of demand, Marshall assumed the utility functions of the different goods to be independent of each other, right? Because as we read before, you can just draw individual demand curves and then you can finally come out to the market demand curve because all of them were not dependent on each other. And the utility function of different goods are independent of each other. In other words, Marshallian technique of deriving demand curves for goods from their utility functions rest on the hypothesis of additive utility functions. That is, utility functions of each good consumed by a consumer does not depend on the quantity consumed of any other good. Okay, that's what Marshall had to say. As had already been noted, in case of independent utilities or additive utility functions, the relations of substitution and complementarity between goods are ruled out. So they're not complement to each other. Further, in deriving demand curve or law of demand, Marshall assumes the marginal utility of money expenditure MUM is general to remain constant. Also, I think something that we read before was that MU or marginal utility derived from money has to remain constant, because otherwise if it keeps on changing, the very meaning of this is the fact that you can incorporate money into the calculation of utility leaves the base. We now proceed to derive demand curve from the law of equimarginal utility. Consider the case of a consumer who has a certain given income to spend on a number of goods. According to the law of equimarginal utility, the consumer is in equilibrium in regard to his purchases of various goods when marginal utility of the goods are proportional to their prices. Already read about this. Thus, the consumer is in equilibrium when he is buying the quantities of two goods in such a way that satisfies the following proportionality rule, right? When MUM stands for marginal utility of money income in general. Okay. With certain given income for money expenditure, the consumer would have a certain marginal utility of money in general. In order to attain the equilibrium position, according to the above proportionality rule, the income will equalize his marginal utility of money expenditure with the ratio of marginal utility and the price of each commodity he buys. Read again. In order to attain the equilibrium position, according to the above proportionality rule, the consumer will equalize his marginal utility of money expenditure with the ratio of marginal utility and the price of each commodity he buys. Exactly what's written here. It follows, therefore, that a rational consumer will equalize the marginal utility of money with this of good X, this of good Y, and so on. Given ceteris paribus assumption, suppose price of good X falls. With the fall in price of good X, the price of good Y, consumers' income and tastes remain unchanged because what? Ceteris paribus. The equality of this with this and this in general would be disturbed because the price of good X has fallen down but everything else remains the same, right? With the lower price than before, this will be greater, right? Because the denominator is falling, so the expression as a whole is going to, the value of expression as a whole is going to rise or be greater than this, because we're assuming that all of them are in equality at first. So this is going to rise or be greater than this or this. It is assumed, of course, the marginal utility of money does not change as a result of the change in price of goods of one good. Then in order to inequality, marginal utility of x or MUX must be reduced. Now, because this has reduced, you have to reduce the numerator as well in order to reduce the expression as a whole, because right now it's greater than mu of y by by, and it has to be equal. And the marginal utility of x or MUX can be reduced only by the consumer buying more of the good x. Okay, because as you increase the amount of a particular good that you're having, the utility keeps on decreasing. It is thus clear from the proportionality rule that it is clear from the proportionality rule that as the price of a good falls, its quantity demanded will rise. Okay, other things remaining the same. If the price of a good is going to fall, the quantity demand will rise, of course, right? This will make the demand curve of a good downward sloping. How the quantity purchase of a good increases with the fall in its price, and also how the demand curve is derived in the Cardinal Utility Analysis is illustrated in figure 7.3. Let's have a look. In the upper right portion, on the y-axis MUX by PX is shown, and on the x-axis the quantity demanded of x is shown. Right, this quantity demanded of x is shown, and on the y-axis mu of x by by x is shown. Given a certain income of the consumer, marginal utility of money in general for him is equal to OH. Okay, this MUM is going to remain constant. The consumer is, let's just underline this point. The consumer is buying OQ1 of good X when price PX1, since at quantity OQ1 of X, marginal utility of money OH is equal to MUX by PX1, okay, at this point. Now when price of good X falls to PX2, okay, the curve will shift upward to a new position. Okay, because the denominator is rising, so basically the value of this expression as a whole is going to increase. So mu of x by px2 is can be something like this, to a new position mux by px2. In order to equate marginal utility with the new mux by px2, the consumer increases the demand to OQ2. Okay. Thus, with the fall in price, the consumer buys more of it. Intuitive? Why it's happening in law of equimarginal utility? It should be noted that no account is taken of the increase in real income of the consumer as a result. Okay, so we are assuming that marginal utility of money remains constant and there's no effect on the real income, because if you see, generally the real income is going to increase if the price of a good falls. The amount of money that you have to spend actually increases, really increases, right? This is because of the change in real income is taken into account, then marginal utility of money will also change, and this would have an effect on the purchase of goods. Marginal utility of money can remain constant in two cases. First, when the elasticity of marginal utility curve, which is the price elasticity of demand, is unity, so that even with increase in the purchase of commodity following the fall in price, the money expenditure remains made on it remains the same. Second, marginal utility of money will remain approximately constant for some changes in price of unimportant goods, that is goods which account for negligible part of the consumer's budget, right? So if anything changes, the real income is not actually changing, so the marginal utility of money is actually not really changing. In case of these unimportant goods, increase in real income following the fall in price is negligible, okay, and therefore we can ignore it. At the bottom of figure 7.3, the demand curve for X is derived. In this lower panel, price is measured on the y-axis, okay, here. So we're falling, the price is falling, the quantity is rising. as in the upper panel, the x-axis represents quantity. When the price of good x is px1, the relevant curve of mu by p is mux by px1, which is shown in the upper panel with mux by px1 as explained earlier. He buys OQ1 of good x, this one. Now in the lower panel, this can be shown to be demanded at price px1, right? So this is the parallel for this. This quantity OQ2 is directly shown to be demanded at price px2 in the lower panel. Similarly, by varying prices, we can come to the quantity demanded at other prices. As by joining points A, B, C, we obtain the demand curve TD. It's a downward sloping curve, which shows that as the price of goods fall, the quantity purchased rises, right? As the price of a good is falling, the quantity that you're demanding of that particular good is basically rising, even for equimarginal utility. Now let's move on to basically the last portion of this chapter, which talks about the critical evaluation of Marshall's Cardinal Utility Analysis. This is something that we read about at the beginning of this chapter, and now we're ending this with a more comprehensive look at the critical evaluations. Cardinal utility analysis of demands, which we've studied above, has been criticized on the various grounds. The following shortcomings and drawbacks of cardinal utility analysis have been pointed out. Cardinal measurability of utility is unrealistic. Cardinal utility analysis of demand is based on the assumption that utility has to be measured in absolute, objective and quantitative terms. In other words, it is assumed that the analysis that in this analysis that utility is cardinally measurable. According to this, how much utility a consumer obtains from goods can be expressed as stated in cardinal numbers, it is 1, 2, 3, 4, so forth. But in actual practice, utility cannot be measured in such quantitative cardinal terms. Since utility is a psychic feeling and is a subjective thing, it cannot be measured in quantitative terms. In real life, consumers are only able to compare the satisfaction derived from various goods on various combinations of the goods. In other words, in the real life, consumer can state only whether a good or a combination of goods give him more or less or equal satisfaction as compared to the other. If I had a burger meal from McDonald's versus I had one burger meal, not sure if they give it, from Burger King, I can probably rate if I like McD more or if I like Burger King more or if I like both of them equally. But I can't state in 1, 2, 3, 4 numbers as to what is the utility that I derive from McD versus what I derive from Burger King versus what I derive from, I don't know, Chili's burger. Okay, I can't give it a number because it's a psychic feeling, and this is something that we've already discussed at the starting of the chapter as well, also during the limitations of equimarginal utility. Hypothesis of independent utility is wrong. Utility analysis also assumes that utilities derived from various goods are independent. Okay, so each good or various goods have utilities that are independent of each other. This means that the utility which a consumer derives from a good is a function of the quantity of that good and of that good alone. Again, this is something that we read before. In other words, the assumption of independent utility implies that the utility which a consumer obtains from a good does not depend upon the quantity consumed of other goods. It depends on the quantity purchased of that good alone. On this assumption, the total utility which a person gets from the whole collection of goods purchased by him is simply the total sum of separate utilities of various goods. Okay, which means that utility functions are not additive. Okay, so are additive. What you're saying is that utility that I derive from the burger is not dependent on the utility that I derive from the sauce that I had with it versus the utility that I derive from the coke that I had with it, the french fries, everything. But if you think about it, it actually depends on all of those factors, right? If I don't have, let's say, coke with my burger or sauce or french fries, I would not probably like that burger as much as I liked it. or if I had Coke alone, I would probably not like it as much as I did when I had it with the burger and the fries and everything. Okay? Neoclassical economists such as Gibbons, Menger, Walras, Marshall considered that utility functions were additive, but in real life it's not so. In actual life, the utility or satisfaction derived from a good depends on the availability of some other good, which may be either substitutes or complementary with each other. For example, the utility derived from a pen depends upon whether ink is available or not. On the contrary, if you have only tea, then the utility derived from it would be greater. But if along with tea you also have coffee, then the utility of tea to you would be comparatively less, right? Whereas pen and ink are complements with each other, tea and coffee are substitutes for each other. So basically, in reality, it the utility or satisfaction that you derive from a particular good actually depends on various substitutes and complements. It is thus clear that various goods are related to each other in the sense that some are complements with each other, some are substitutes for each other. As a result for this, the utilities derived from various goods are interdependent, that is, they depend upon each other. Therefore, the utility obtained from a good is not the function of the quantity alone, okay, but also okay, depends upon the existence or consumption of other related goods, complements or substitutes. It's thus evident that the assumption of the independence of utilities by Marshall and other supporters of marginal utility analysis is a great defect and shortcomings of their analysis. As we shall see below, hypothesis of independent utilities along with the assumption of constant marginal utility of money reduces the validity of Marshallian demand theorem to the one commodity model only. We'll see this before. We'll see this in some time. Assumption of constant marginal utility of money is not valid. As important assumption of cardinal utility analysis is that when a consumer spends varying amount on a good or various goods, or when the price of a good changes, marginal utility of money remains unchanged. But in actual practice, that's not correct. When a consumer spends his money income on goods, money income left with him declines, right? But the decline in money income of the consumer as a result of increase in his expenditure on goods, the marginal utility of money to him rises, right? Because he has less money now. Further, when price of commodity changes, real income of the consumer also rises. This is something that we discussed just a while ago. With this change in real income, marginal utility of money will change, and this would have an effect on the demand for the good in question, even though the total money income available with the consumer remains the same. Even though the total money income that he had is still the same, in real terms, or the marginal utility of money actually is changing at different points. But utility analysis ignores all this and does not take cognizance of the changes in real income and its effects on the demand for good following the change in price of a good. As we shall see below, it is because of the assumption of constant marginal utility of money that Marshall ignored the income effect of price change, which prevented Marshall from understanding the composite character of price effect. We read at the start of the chapter that Marshall only took into account the substitution effect of price change while explaining the demand curve. So he basically also could not understand the composite character of price effect. That is, the price effect is a sum of substitution effect and income effect. Slutsky. Moreover, as we shall see later, the assumption of constant marginal utility of money together with the hypothesis of independent utilities renders the Marshall's demand theorem to be valid in case of one commodity. Okay, when you have only one commodity, then all this kind of sort of adds up. Further, it is because of the constant marginal utility of money and therefore the neglect of the income effect by Marshall that he could not explain the Giffen paradox. As has been explained earlier, according to Marshall, utility from a good can be measured in terms of money, that is how much money a consumer spends is prepared to sacrifice on the good. We already read about this as well. But to be able to measure utility in terms of money, marginal utility of money itself should remain constant, right? This is what we discuss as the basis of this saying that you can put utility in numbers, in terms of money that you are prepared to spend on them. Therefore, assumption of constant marginal utility of money is very crucial to the Marshallian demand analysis, right? On the basis of constant marginal utility of money, Marshall could assert that utility is not only measurable in principle but also measurable in fact. But as we shall see below, in case a consumer has to spend his money income on a number of goods, there is a necessity for revision of marginal utility of money with every change in price of a good, right? So the money income that he has, real amount of income that he has in case of a decrease in price of a certain good would actually increase. In other words, a multi-commodity model, in a multi-commodity model, marginal utility of money does not remain constant. Now, when it is realized that marginal utility of money does not remain constant, then Marshall's belief that utility is measurable in fact in terms of money does not hold good. This is the limitation of cardinal utility. However, if in marginal utility analysis utility is conceived only to be measurable in principle and not fact, then it practically gives up cardinal measurement of utility and comes near to the ordinal measurement of utility, right? So measurable in principle, you can sort of compare or give weights to it. Okay, then you're coming near to what ordinal measurement of utility essentially is. Marshallian demand theorem cannot genuinely be derived except in a one commodity case. Hicks and Majumdar have criticized Marshallian utility analysis on the grounds that Marshallian demand theorem cannot genuinely be derived from the marginal utility hypothesis except in a one commodity model without contradicting the assumption of constant marginal utility of money, right? So whatever we read here, it would probably not hold at all, because MU is going to change with this fall in price, right? In other words, Marshall's demand theorem and constant utility of money are incompatible except in a one commodity case. As a result, Marshall's demand theorem cannot be validly derived in the case where a consumer spends his money on more than one goods. In order to know the truth of the assertion, consider a consumer who has given amount of money income to spend on some goods with given prices. According to utility analysis, the consumer will be in equilibrium when he is spending money on goods in such a way that the marginal utility of each good is proportional to its price, right? Let us assume, you can underline this. Let us assume that in his equilibrium position, consumer is buying Q1 quantity of X at a price Py. Marginal utility of X in his equilibrium position will be equal to the price P1 multiplied by the marginal utility of money. Okay. Thus, in equilibrium position, this is going to hold from whatever we basically just brought P here. Since the consumer is buying Q1 quantity of good X at price P1, he is spending P1 Q1 amount of money on it, right? At P1 you're buying Q1 units of good X. Now suppose the price of good X rises from P1 to P2. With this rise in X, all other things remaining the same, the consumer will at once find himself in disequilibrium, right? For the marginal of good X will now be less than the higher price P2, right? Marginal utility of good X will now be less because of the higher price P2 multiplied by the marginal utility of M, which is assumed to remain unchanged and constant. We are assuming it to be constant. Now this will be the case, right? All of this just stated in mathematical terms. In order to restore this equilibrium, the consumer will buy less of good X because the price is increased, so you're going to buy less of that good to come back to your equilibrium, so that the marginal utility of good X would rise and become equal to the product of P2 and NUM, right? Suppose in this new equilibrium position, he is buying Q2 of good X, which will be less than Q1. Okay, now you're buying Q2 of good X because you have to buy less of that good because the price is increased. With this, he is now spending P2 Q2 amount of money. Now the important thing to see is that whether his new equilibrium P2 Q2 on good X is equal to, smaller than, or greater than P1 Q1. This depends upon the elasticity of marginal utility curve, that is price elasticity of demand. If the elasticity of marginal utility of good X is unity, then the new expenditure on good X P2 Q2 after the rise in price from P1 Q1 will be equal to the initial expenditure P1 Q1, right? Because marginal utility curve for good X is unity, it's 1, right? When the monetary expenditure made on the good remains constant as a result of change in price, then the Marshallian theory is valid. But constant monetary expenditure following the price change is only a rare phenomena, right? It does not really hold. However, the Marshallian demand theory breaks down when the new expenditure P2 Q2 after the rise in price, instead of being equal, is smaller than or greater than the expenditure P1 Q1. If elasticity of marginal utility curve is greater than 1, then the new expenditure P2 Q2 after the rise in price from P1 to P2 will be less than the initial expenditure P1 Q1. On the other hand, if the elasticity of marginal utility is less than unity, then the new expenditure P2 Q2 after the rise in price will be greater than the initial expenditure P1 Q1. It will become more intuitive once you write it down and try to probably even draw a graph. Now, if the new expenditure P2 Q2 on good X is less than the initial expenditure P1 Q1 on it, it now means more money will be left with the consumer to spend on goods other than X, right? So if the new expenditure is less than the initial expenditure, you have more money left to spend on goods other than X. And if the new expenditure P2 Q2 on good X is greater than the expenditure on P1 Q1, then you have less money to spend on other goods. In order for that consumer to spend the entire money available with him, then in case of new expenditure P2 Q2 on good X being smaller or greater than P1 Q1, the expenditure on goods other than X, and therefore consumers' demand for them will also change, right? But in Marshallian theoretical framework, this further adjustment on goods other than X can occur only if the unit of utility measurement, that is the marginal utility of money, is revised or changed, but Marshall assumes it to be constant. Marginal utility of money to be constant. Thus, we say that marginal utility of money cannot be assumed to remain constant when the consumer has to spend his in money income on a number of goods. In case of more than one good, basically all this is the explanation of the fact that in case of more than or multi-good economy or multi-good demand curves, this does not hold. Marshallian law of demand does not hold. Marshallian demand theorem cannot be genuinely derived when keeping the marginal utility of money constant. If in Marshallian demand analysis the difficulty is avoided by giving the assumption of constant marginal utility of money, then money can no longer provide the measuring rod, and we can no longer express the marginal utility of commodity in units of money. If we cannot express marginal utility in terms of common numeraire, which money is defined to be, the cardinality of utility could be avoided for any operational significance. Only in case there is one good on which the consumer has to spend his money, Marshallian demand theorem can be validly derived to conclude, except in a strictly one commodity world, therefore the assumption of a constant marginal utility of money would be incompatible with the Marshallian demand theorem. So for Marshallian demand theorem to hold, you have to have one commodity economy. Cardinal utility analysis does not split up the price effect into substitution and income effect. The third shortcoming of cardinal utility is that it does not distinguish between the income and substitution effect of the price change. We know that when a price of good falls, the consumer becomes better off than before, and the fall in price of a good brings about an increase in the real income of the consumer, because we are assuming that marginal utility is constant. We're basically not even taking this into consideration. In other words, if with the fall in price the consumer purchases the same quantity of good as before, then he would be left with some income. With this income, he could be in a position to purchase more of this good as well as other goods. This is the income effect of the fall in price and quantity demanded of a good. Thus, when the price of a good falls, it becomes relatively cheaper than other goods. As a result, the consumer is induced to substitute that good for others. This results in increase in quantity demanded of that good. This is the substitution effect of the price change, the quantity demanded of a good. With the fall in price of a good, quantity demanded of it rises because of the income effect and substitution effect. But cardinal utility analysis does not make clear the distinction between the income and substitution effect of price change. In fact, Marshall and other exponents of marginal utility analysis ignored the income effect of the price change by assuming the constancy of marginal utility of money, like I just said. Thus, according to Majumdar, the assumption of constant marginal utility of money obscured Marshall's insights into the truly composite character of the unduly simplified price-demand relationship. Unduly simplified. They explained the changes in demand as a result of the change in price of good alone on the basis of substitution effect. Thus, marginal utility analysis does not tell us about how much quantity demanded increases due to the income effect and how much due to the substitution effect as a result of the fall in price. Hicks states that the distinction between income and substitution effect of a price change is accordingly left out by the cardinal theory as an empty box which is crying out to be filled. In other words, Majumdar said the efficiency and precision with which the HL approach can distinguish between the income and substitution effect of a price change really leaves the cardinal argument in a very poor state. So to say, Hicks and Allen are going to take both of these into consideration while giving out the ordinal argument. Marshall could not explain the Giffen paradox. By not visualizing the price effect as a combination of substitution and income effect and ignoring the income of the price, Marshall could not explain the Giffen paradox. He treated merely as an exception to the law of demand. In contrast to it, indifference curve analysis has been able to explain, which is the Hicks-Allen approach, satisfactorily the given goods case. According to the indifference curve analysis, in case of a given good paradox or the given good negative income effect of the price change is more powerful than substitution effect, so that when the price of a given good falls, the negative income effect outweighs the substitution effect with the result that quantity demanded of it falls. You're going to see this very clearly once the graph and everything is in place. I'm sure it's going to come in the next few chapters. But what it basically is trying to say is that given goods case, which is when the price of a commodity given good rises, the demand of that also rises, was ignored by Marshallian theory. Why? Because he did not assume the income effect as an effect at all. He said that the given goods case was merely an exception to the law of demand, he states. Thus, in case of the given good, quantity demanded varies directly with the price, and Marshall's law of demand does not hold good. It's because of the constant marginal utility of money and therefore the neglect of income effect of the price change that Marshall could not explain why the quantity demanded of given good falls and the price falls and rises when the price rises. This is a serious lacuna in Marshallian's utility analysis of demand. Marginal utility analysis assumes too much and explains too little. Marginal utility analysis is also criticized on the grounds that it takes more assumptions and also more severe ones than in the case of ordinal utility analysis of indifference curve technique. Marshall marginal utility analysis assumes, among others, that utility is cardinally measurable, and also that marginal utility of money remains constant. Higgs silence indifference curve analysis does not take these assumptions, and even then, it is not only able to deduce all the theorems which cardinal utility analysis can, but also deduces a more general theorem of demand. In other words, the indifference curve analysis explains not only that much as cardinal utility analysis does, but gives more. So, even goes further, and that too with fewer and less severe assumptions. Taking less severe assumptions of ordinal utility and without assuming constant marginal utility of money, IC analysis is able to arrive at the conditions of consumer's equilibrium, namely equality of marginal rate of substitution with the price ratio between the goods, which is similar to the proportionality rule of Marshall. Further, since IC curve analysis does not assume constant marginal utility of money, it is able to derive a valid demand theorem in a more than one commodity case. Because as we said, it just breaks down with more than one commodity, the Marshall demand theorem. It can be explained in the next few chapters that IC analysis is able to explain the Giffen paradox, but Marshall, with his marginal utility analysis, could not. In other words, IC analysis clearly explains why, in case of Giffen goods, quantity demanded increases with the rise of price, decreases with the fall. IC analysis explains even the case of ordinary inferior goods other than Giffen goods in a more analytical manner. It may be noted that even in the valid demand theorem could be derived for the Marshallian hypothesis, it would still be rejected because better hypothesis of indifference preference analysis was available, which can enunciate more general demand theorem covering the case of Giffen goods with fewer, less severe and more realistic assumptions. Because of the above drawbacks, cardinal utility analysis has been given up in the modern economic theory, and demand is analyzed with new approaches to demand theory. We shall discuss these modern approaches to the demand in the following chapters. So basically, the main limitation is that cardinal measurability is unrealistic, and assumption of constant marginal utility. All of them are basically just derived from this particular thing. Okay? All of the limitations are derived from both of these limitations, which are basically the assumptions of Marshallian demand theory, the basis of which we have also found out through this analysis is completely wrong or only applies to a one commodity economy, which is not really applicable in the real economy. Okay, you can go through these questions to sort of get an idea of the chapter yet again. It will help you go through the chapter once more. Thank you so much for watching this. Have a great one.